Welcome to 1.2, Transformations of Linear and Absolute Value Functions, Part 2. We're going to begin this lesson with talking about stretches and shrinks. First of all, our textbook does talk about horizontal stretches and shrinks, but most of these can be described as vertical stretches and shrinks, so we're not going to do the horizontal. So let's take a look at vertical stretches and shrinks. The graph of y equals a times f of x is a vertical stretch or shrink by a factor of a. So this number out front, we're multiplying the entire function and all the y values by a certain number. And if you look over here at the picture they give us, if a is greater than 1, okay, so this number right here, if it's bigger than 1, like 1, 2, 3, something bigger than 1, notice the slope is steeper, okay? This is called a vertical stretch. Let's label that. So this is a vertical stretch. Notice the y value, or not the y value, the red equation. Notice how it's not as steep. That is when a is between 0 and 1. That's like 1/2, 1/3, 0.2, anything like that. That is called a vertical shrink. So let's take a look. Let's look at example 3. Writing stretches and shrinks of functions. Part A says write a function g whose graph is a horizontal shrink by a factor of 1/3. Now, since we are not doing horizontal, I'm going to change that to vertical. So let's look at A. Write a function g whose graph is a vertical shrink by a factor of 1/3. So I need to take this entire function, f of x, and multiply it by 1/3. So 1/3 times f of x equals 1/3 times the absolute value of x minus 3 minus 5. Then you distribute. We cannot multiply inside of an absolute value, so that becomes just sitting on the outside, 1/3 times the absolute value of x minus 3. And do 1/3 minus 5. So 1/3 times -5 is -5/3. And the 1/3 f of x is now called g of x. So we're going to call this g of x. So we're going to graph this and look at it on Desmos. So we'll graph the original, which is the absolute value of x minus 3 minus 5. And there's the original absolute value function. Now let's look at the transformed. So 1 divided by 3. Now notice my cursor is still in the denominator. You want to make sure you get that out of the denominator by using your arrow key. And then type the absolute value of x minus 3. And then minus 5/3. So minus 5 divided by 3. And you notice that each height from the y-axis of the new graph is 1/3 of the distance from the original. So that length right there, you take 1/3 of it and it is right there. So it made all the heights 1/3 of the height of the original. So we notice it is a vertical shrink by 1/3. Okay, it brought everything in close to the x-axis by a factor of 1/3. So everything's 1/3 the height. Okay, let's look at B. B is a function h whose graph is a vertical stretch. So this one's a stretch, not a shrink, of the graph by a factor of 2. So we're going to do the same thing, except we're just going to multiply by 2. So 2 times the absolute value of x minus 3 minus 5. I'm going to distribute. So remember, we can't multiply inside the absolute, so it's just 2 times the absolute value of x minus 3. And then 2 times negative 5 is a negative 10. And we call this one h of x. So let's graph h of x. H of x is 2 times the absolute value of x minus 3 minus 10. And you notice how the green graph, which is part B, is stretched vertically by a factor of 2. It's actually every height is doubled. Let me write on the graph and just show you that. So you look at the original graph, the height from here to here is, what's that, 5 units? The new one, h of x, is 10 units away from the x-axis. So every height gets doubled. Okay, so that's a vertical stretch. You notice the sides are steeper than the original one, which was in red. So let's take a look at number 4. We're combining transformations. Let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation of 3 units up of the graph of f of x equals x. Write the rule for G. So let's just do one at a time. Okay, let's do first, it says a vertical shrink. So we're going to multiply the function by 0.25. So f of x, multiply it, which is multiply both sides. And since the right side is only x, this becomes 0.25 times x. Okay, then we're going to translate it 3 units up. Well, up and down is on the outside of the function, so I'm just going to plus 3. So 0.25 times f of x plus 3 on the outside there. So we do what we do to one side, we do the other. And this right here is g. We call that g. So this is g of x, not the highlighter, folks. Sorry about that. So this is g of x equals 0.25x plus 3. And you can totally check this on a graphing calculator to check both, making sure that it was a vertical shrink by 0.25. And you know that from graphing slopes, 0.25 is actually 1/4. Rise over run, rise 1, run 4. We know that's a easy grade slope. It's a less steep than the slope of 1. So we know it's less steep. All right, so let's look at example 5. Last one. Modeling with mathematics. You design a computer game. Your revenue for X downloads is given by f of x equals 2x. Your profit is less than 90% of the revenue for X downloads. Describe how to transform the graph of f to model the profit. What is your profit for 100 downloads? So we've got 2 things. We have to make a function f to model the profit and then use that. Okay. So this is when reading really becomes important in math. So you have to think about what you're doing. It says your profit is $50 less than 90% of the revenue. So what do I find? Do I find 90% of the revenue first or 50 less? Well, it's 50 less than 90% of the revenue. So the first thing I do is find 90% of the revenue. So I take 90% of f of x, so 90% is a decimal, is 0.9. So I'm going to multiply f of x by that. So 0.9 times 2 is 1.8 x. Then, I'm just going to write that down, copy it down. Then, the second part is we take $50 less. So we'll subtract 50. So subtract 50 from both sides. So our function, and we're going to call this, did they tell us what to call it? They did not. We'll call it P. We'll call it P of x for profit. So P of x equals 1.8x minus 50. The second part of this question asks, what is your profit for 100 downloads? So guess what? Remember what X is? X is the number of downloads. So we plug it in into the function we just wrote. So we do P of 100 equals 1.8 times 100 minus 50. So that is 180 minus 50. So that is 130. So $130 is our profit when we have 100 downloads. That is the end of this lesson. You will have a big ideas assignment. And if you have any questions, let me know. Bye.